All right. Well, technical difficulties. Thank y'all for joining us today for our first episode of the Dragon's Forge podcast. Y'all get the honor of being our first guest, and we're very happy to have you on. So, the way this is going to work is we basically have a slide set assembled with some questions. Some of them are about your team, some of them are just fun trivia, and there's one very, very important question at the end that we'll get to. But feel free to ask us any questions, and it's basically just going to be a conversation, but these slides are the jumping off point. So, David, if you want to go ahead and get started.
Perfect. So first, can you tell us a little bit about yourselves, where y'all come from, and what are some interesting facts about your team?
Yeah, so we're a 11 years friends and family team. It might be 12 now. Uh, and so we're a community team from Plano, Texas. We've been around for a while, and some interesting facts about us. Let's see. Our logo actually was designed at one of our first meetings. As you can see, it's a pretty cool logo. Um, I would never be able to design that, and it was really cool because some of our alumni, like they heard the name and they just kind of started drawing, and this is what they came up with.
That's awesome. And how long have each of y'all been on this team?
Pierce, you want to go first?
Sure. So I've been on this team for 1 year, like the previous season, and I joined last season. It was my first year. It was a really fun experience, and I'm looking forward to this upcoming year, especially because water game.
Yeah.
Yeah.
Yeah, this is going to be my fourth season on 71-72, and I'm definitely looking forward to see how the game changes with the new extending limit.
Yeah.
Because, we were
Yeah.
talking about it, and for like the last 3 years, none of our robots would have been legal, according to this new rule set.
We've definitely had at least one that wouldn't be legal. I think for what was it? Power play, we had a robot with about a 4.5 or 5 foot extension. So yeah, we can relate to that. All right. Well, I guess we can get on to the next first real question. This one is trivia. So we're starting off easy and we'll get progressively harder. So do y'all know who founded First and First Tech Challenge?
I don't know about First Tech Challenge, and I don't know if these are like the exact founders, but I know Dean Kamen and Dr. Woody Flowers are very strongly associated with First in general. So if I'd have to guess, it would be one of those two.
All right. Pierce, do you have any guesses?
My guess would be Dean Kamen because of how much presence he has currently. But if it's not him and it was some previous person, then I do not know.
Y'all are right. It's Dean Kamen, and that's why we have the Dean's list since he
Yeah.
founded it. So awesome. Off to a good start. All right. So Frank, you're our head of hardware, so you want to take this one away?
Oh yeah, so I was wondering like what your design process, like how you go through your design process once the FTC game kickoff happens. Like what's your kind of timeline and thought process behind everything?
Yeah, so the way we kind of, I guess, like the biggest criteria for everything we build, everything we design and program is what scores the most points consistently. And so the way we kind of qualify what like how a high scoring robot is we're always thinking about what are the kind of robots and scoring that we're going to see in World's Finals, right? And that's kind of what we aim for, from the way we kind of plan our autonomous, from the way we plan our teleop and our endgame. And so more specifically, usually, kickoff starts and we start with the Google Sheet. We document what tasks there are, how much they're worth in points, how difficult they are, and we decide, okay, which are the first tasks we want to pursue. And almost every year, it's usually autonomous because autonomous is where you can score a lot of points and you can do them pretty consistently. And that's really what kind of sets you apart from other teams because having a good teleop is definitely difficult, but by the end of the season, a lot of teams manage to have that. But having a consistent and high scoring autonomous, that's something that's a lot more difficult for most teams to get, and that's what really sets you apart. And so after we design a robot that we think is going to be great for autonomous. Usually in most games, if you have a robot that's going to score high in autonomous, it's going to tend to score high in teleop. And so by taking that robot, tuning it a little bit and doing a lot of driver practice, we can get a fairly consistent teleop. And really a big part of getting a good teleop is driver practice. I guess I've strayed a little bit from your question. Um, but design ideas specifically, we do a lot of research into old robots. If they're previous game elements, then we'll look at the games and the robots that we've seen that are really, really good for previous games that use the same game elements. For example, in Fray Frenzy, we saw, okay, they're doing balls and cubes again. So we went and we found the robot that we thought had the best intake in Rover Ruckus, and that robot was Data Force's robot. And so looking at that, we contacted them, we got their advice and their dimensions for their intake. And so we took that and we made our own prototype, and then we started iterating on that. And that's kind of how we made one of our fastest intakes to date. Pierce, do you have anything to add?
Mainly that early in the season, after we've decided like what scores the highest points. Normally we have like either one or multiple people, we like to draw up designs and we compare them. And then if we see any that like seem worth pursuing, then we'll try exploring them through CAD and then testing them through multiple iterations. And then whichever ones seem to work better, like any minor changes or major changes, then we'll implement those and just gradually improve on any designs that we do build.
Nice.
All right,
And
cool.
you mentioned you guys iterate, and so of course you have to do that to improve throughout the season, be competitive. How large of gaps do you have between iterations? Do you ever have like a gap where it's like this is on, say, robot A, and then the next meet you come out with a completely different robot, different drivetrain? Do you ever have changes that are that big? Or do you plan it out well enough that you never have that sort of problem?
So we have had, at least from my experience in this past year, we've had some changes like that. So like I think after halfway through like our leagues, we decreased the size of our chassis by about, I think it was like around like 1 inch or something. So to do that, we had to basically take apart the robot in half and then rebuild the middle section of it. And then for the smaller piece of the robot, a lot of the iteration happens before we assemble the entire robot. And then once we assemble the entire robot, it's built mostly modularly, so we can take off a piece of the robot that's like we improved upon and then put on the new piece without having to change too many of the other designs.
Yeah, to add on to what Pierce said, usually we start with a prototype, and then somehow we get a good enough prototype where it goes on the robot. And then after that, we make like a final version. We're never done building the robot. And so once we get like a version that we're, okay with using in competition, we start looking at how can we improve it in like the smaller ways, making it ever so slightly better. And then those small changes kind of accumulate over time to make us even better. As for large changes, I wouldn't say we avoid them as a result of good planning, but more of, our design philosophy tends to have us building a robot that we think is going to be competitive and it's the right robot for us. But it does happen that, we're in the middle of the season, we're like, okay, this robot we don't think is going to do as good as the robot in World Finals. And, it's completely not the design we want to keep going with. And so one example of that was in Power Play, around December, we decided, okay, we're going to completely switch the robot design. And that's when we came up with the crazy two-arm extending drivetrain design. And so it wasn't the biggest change in the sense of, we one day just put on a completely, like, we just started going to competitions with a completely new robot. There was definitely a lot of testing and prototyping involved before we even decided to switch robots. It's an idea we had in the works, and we were, prototyping the arms, making sure that the design had potential. So we do big changes sometimes, like switching, whole designs, redesigning the entire robot. But we also try and minimize the risk by doing a lot of prototyping before we choose to switch.
Right. So it sounds like y'all have a good balance of like the size of your iterations and not doing too much where it becomes a risk. So that's great. All right. I think we can go on to the next question.
Pierce, you want
All
to
right.
take this one?
Normally we decide this by making a prototype of an idea that we think is going to be at least it's feasible that it could be good. So you just make a prototype of it, see how well it performs, and then we just mainly go based off of that. And then like if there's any like things that are obvious that you can change to make it so that it would work well, then we change that. Just iterate on the prototype. But if it looks like it's just not gonna work as well, then we see if there's other options that we could explore.
Yeah, the
And
ultimate, test for whether or not,
Yeah.
or to decide between two different designs is, what scores the most and does it consistently. Yeah, and so as Pierce said, we try and prototype as much as possible, which is how we figure out what scores the most and consistently.
and when you say you're testing prototypes, does that kind of involve like, all right, we're gonna sit down and test this intake 500 times and like time it and then compare it to this other intake going 500 times and like compare the average times, or is it a bit more or less scientific than that?
Yeah, so um, say for the example on intakes, right? A lot of our, how we say um, this one is going to score more and do it consistently is definitely less scientific than what you mentioned. It's like a out of 10 times, how much does this intake jam? So that is one well, somewhat scientific thing we do. And then the other one is, this one looks like it's going to go fast, or it intakes pixels faster. It's more responsive when it touches the pixels. But there are times, and then this is kind of the first season we actually really thorough with this, when we do like the full scientific and documentation. Um, so with our drone launcher this year, we had a ton
Yeah.
of inconsistency, right? And so we tried to minimize that. We did a lot of redesigning, and at some point we decided, okay, we're going to sit down, we're going to launch like, as you said, 500 planes. We're going to see exactly where they go. We're going to see what zones. We're going to figure out, how many times do we get zone one? How many times do we hit the wall? And we're going to use that to compare between designs. And that's the first time that, in my experience, we've done something that rigorous.
That's cool. Can I ask a follow-up question?
Yeah.
How do you test like these different iterations? Like when you have a functional robot and you're building a prototype that you want to implement on it, but you don't want to like take the whole robot apart to put it on yet. Do you have like a separate robot test platform for those prototypes?
It depends on what we're testing. If we're testing something that mounts to like just like a basic, I don't know, U-channel height on like a drivetrain, like an intake, for example, we
Mhm.
could just screw it onto like a something that's a similar height and then like with similar approach, like on like little rollers or something to intake from a stack. But if it's more like an internal mechanism, like a claw or slide mechanism, we will just see how well it intakes, like on a separate like simulated platform. That's not exact, but it's similar and close enough, and see how well it performs something that looks like similar to how it would be on the robot. And
Mhm.
then just see how well it performs from there.
Yeah. All right, thank you.
All right, moving on. I think we have one more hardware question for y'all. And Duncan, if you want to take this one.
Sure. This is kind of a topic that has a lot of relevance to our team. It's how should I keep track of personal specific goals and instructions within the team? Or how do you guys do it, I guess?
So the way we do it is, at least for hardware, is we say at the beginning of the season, okay, here is the kind of overall robot we want to design. Here are the various components of this overall robot design. Who wants to do what, right? And then we kind of split up the tasks, and then each person is responsible for that component. And then, we also don't kind of leave them to figure it out on their own. There's a lot of help from mentors and coaches, looking over the CAD to make sure that it's not something that's going to be dangerous or something that's just not going to work. Also help from people who are also designing, because obviously when you're designing different components that are going to work together, you're going to want to know what what you're designing is going to have to interact with what someone else is designing. So there's also working together there. And so I guess a lot of the like very season specific goals are broken up into components that each person kind of takes responsibility for. As for the overall goals, that's something that we kind of leave up to the individual. Say if you want to learn programming, we're happy to teach you. We'll give you everything you need, and any questions you have, we'll answer. But if you don't ask us the questions, we're not going to go out of our way to answer them. That's at least during the season. If we have people who expressed interest in a topic before the season starts, if it's their goal to learn programming, we make sure before the season starts that we give them a chassis. We give them, here's a series of tasks to try, and here's, some possible issues you run into and how to get around them. So I hope that answered your question.
Right on.
Can I ask another question about how do you exactly like implement each other's own like sub-module designs on your CAD program? So like I know Fusion 360 has, or and SolidWorks has the ability to have like different components in the design, and then they get updated on the main assembly. How do you like give them like once you have the design of the chassis and like a specific uh volume requirement, is that like how you set it, or how do you set it?
Fish, do you want to talk about this one?
Yes, for this, so we have like a main chassis model, so all the other parts are then like attached to that. And we have like a rough estimate of where everything is gonna go beforehand, and if it's like if size constraints or other things are really a problem, then we'll usually like sketch it out beforehand and find the approximate dimensions where everything goes.
Okay.
And then once we have like the actual CAD models, everything put together, we just make sure it all meshes together in CAD. So maybe change a few measurements, make it exact. And then generally that works well. And then yeah, this generally works well.
Awesome. All right, I think we can move on to our next trivia question. I do want to remind y'all, if you would like to ask us any questions about the same stuff or something different, just to see what our team does, feel free to, but you don't feel obligated to. All right, David, do you want to go back one? Yeah. All right. So this one's another pretty easy one. Who coined the term gracious professionalism?
Okay. So this one is definitely Dr. Woody Flowers. Um, probably because there's a picture of him on the slide.
Yeah.
Yeah, that was a pretty big hint. That one wasn't too bad. Although I think y'all will like the last one. It's pretty fun. So, all right. We can move on to software. Neil, this is all you.
All right, guys. So I'm the head of software on some assembly required. So I had a couple quick questions. So how do you guys come up with like programming strategies for each game, and like implementing things like sensors and odometry and things like that? And like, what are your like timelines for that kind of situation?
Okay. So I'm gonna preface by saying take every single one of our answers with a big grain of salt, as me and Pierce are not the programmers on our team. We are both do hardware and design.
All good.
Okay, so software strategy is really paired up with our hardware strategy and our overall game strategy. So in the sense of, we want to score as much as possible. Part of that is reducing human error, which means, we want it to be as easy for the robots or easy for the drivers to drive as possible. You want a lot of automation. You also don't want it to be over automated where, the robot is going to go do something really bad, like go and commit a penalty and you can't stop it. So that's something that you also want to be aware of. And so a big part of our software strategy is to try and make it as easy to drive in teleop as possible. The second part of that be, autonomous. And so in autonomous, usually our goal for the season is to get, a really high scoring, really consistent autonomous. And so with that comes, consistent localization, sensors that are, that aren't going to slow down your read times as much. So correct me if I'm wrong, but I believe, I2C is something that is a lot slower of a read time than, say, an analog sensor. So try and incorporate analog sensors and things that are going to give you a really quick detection, like an on and a really consistent detection, like an on and off, rather than something where you have to interpret the data that the sensor is giving you a lot more. We try and, have encoders on every single one of our motors that really needs it. So, encoders on all of our drive motors, encoders on our elevators and all of that. We try and have fail safes. So say our elevator slips, we make sure that we have a limit switch on every single one of our elevators so that every time or extension. And so every time the extension comes back and hits that limit switch, we know exactly where it is. And so that we are able to counteract, a belt slipping and suddenly every single one of our presets is off. So yeah, things like that, having dynamic programming and like smart programming where the robot can adjust for various issues. I think one great example of that this year is we use the Husky lens to detect the pixels in autonomous, right? And so, especially at the beginning of the season, we had issues with localization where we could be off enough where, we hit the stack and we don't intake any pixels, or we don't hit the stack at all. So we started using the Husky lens where, okay, it sees a white pixel and highlights it with a box, and that's in a certain part of the frame. And so we say, okay, if it's not centered in the frame, strafe towards the side that it is on. And so that gets us closer to the pixels, and the intake does the rest of the job. And I believe we also use kind of programming structures that make it easier to not only program the robot, but also more efficient, like state machines and things like that. As I mentioned earlier, we try and focus on localization. So one thing we do is we actually do not use dead wheel odometry. That's not anything against dead wheel odometry specifically. It's not that we start every season and we say, okay, this season we're not using dead wheel odometry. It's more of we start this season and we're like, oh, we really want the pixels or we really want to be able to drive over the pixels, and an odometry pod is going to kind of mess that up. It might get stuck, make the wheel get stuck on a pixel, and it might make the robot slower. And so we decided this season specifically, we're not going to have odometry pods in order to conserve our ground clearance. And, a decision like that means you have to use other sensors to localize. Because driving coders are notorious for slipping, we used April tags to detect the April tags on the backboard. So we relocalize every time we score. We use distance sensors against the wall, actually ultrasonic sensors. And so that tells us, okay, how close are we to the wall? And so between those two, up until the end of the official season, we were able to get pretty good localization, either at or around the level of dead wheel odometry. And then after the season ended, a new sensor came out called the OTOS. And so that's something we started using 2 weeks before the Maryland Tech Invitational. And that's a sensor that acts kind of like a mouse. And so it's a laser that points down at the field, and when you move around, it gives you your position back along with has an IMU installed, so more data. And so with that, we were able to get results that, from our previous experience with dead wheel odometry, were just as good, if not better, and allowed us to get a really consistent autonomous. So
So,
that's my rant.
sorry.
You can.
Yeah. So with OTOS, I was like considering it. Do you think that like error correction would be something that you could do, like including both like that and dead wheel odometry, or is it something that you should just like your experience with it was good enough that you didn't need to?
Yeah, so we didn't stop using April tags and distance sensors and driving coders. We just kind of integrated the OTOS as like our base. Here's where our robot is,
Okay.
and then we said, okay, the distance sensor is telling us we are 5 inches away from the wall. The OTOS is telling us we're 7 inches away from the wall. Um, we are going to intake when we are 3 inches away from the wall according to the distance sensor. So we're not exactly correcting where the robot thinks it is. Besides when we are scanning the April tags, and that's kind of our master thing. If the April tag tells us we're somewhere, we're like, okay, we are exactly there. But for the other sensors, we just try and kind of make it so that if the OTOS gets us pretty close to where we want to be, and then the other sensors make sure that we're not hitting the wall or doing something we wouldn't want to do. And so, specifically for your question, augmenting it with dead wheel odometry, I think rather than using dead wheel odometry along with the OTOS, it would be probably a better idea to use other things that aren't focused on where your robot is and tracking your robot's motion, but rather tracking other things on the field where you know where they are. A lot of teams this season used ultrasonic sensors to track the walls and April tags, of course. So using those two things along with either dead wheel odometry or OTOS would probably be better than using OTOS and dead wheel odometry because they both would kind of accumulate the same kind of error because they're both tracking the motion of your robot rather than your robot's position relative to the field.
Right. Okay. And also like this year we were having a lot of difficulty with like, I guess we didn't use April tags the entirety of the season just because it like didn't work with the way we had placed our camera and things like that. But like your April tag, like you used it to like in auto, would you use April tags to like orient yourself, or would you just um know exact because of your OTOS or your dead wheel odometry, you knew exactly where you were on the field at all times?
We definitely use the April tags to localize ourselves. That was,
Mhm.
the thing where we said like that was our end all be all for localization. So if if the April tag was telling us we're on the other side of the field, we wouldn't have any way to really correct for it. Maybe one of the other sensors would kick in, but we found it that, it was accurate enough that we were willing to risk that level of dependence. And so one issue that we had was, when you're moving, it's harder to detect the April tag. We were using a Logitech C920, and so this season we're planning to try using global shutter cameras so that you're getting better detection of April tags while you're moving.
Okay. All right. Next slide, please, David. So this is like a very basic general question, but like, what is your general like strategy for like testing and eliminating bugs, especially like in autonomous and things like that?
So usually, your errors are pretty obvious if your code doesn't compile.
Right.
But if it does, that's when you're like, oh, shoot, we have an error, but the code compiled. Now you have no idea where it is. That's where we really use telemetry to try and figure out, and we have like log files. So when something goes horribly wrong in autonomous, we can download the log file and be like, oh, this is where the robot thought it was. This is what the robot or the sensor was telling the robot. And we get like, all the values so we can go back and figure out um, where we get, and this is a lot easier when you have a state machine. So you know exactly what state you're in, what readings you're getting from your sensors, and using that, you can pretty quickly, relatively quickly, debugging usually takes a while, figure out where your error in your code is.
So also this is like a separate question, but how like extensive is your state machine? Like, does it like account for like, so in your state machine, would it be per component? So like your arm being extended a certain distance and your state machine would control that? Or would it be more like certain components of like the game, like uh if there's a pixel here, do this, or like other kind of, you know, more like big picture type of like steps?
Yeah, we definitely use more big picture kind of states. So, intake, transfer, score, or those are kind of the basic ones, and then there are ones in between. Um, Also, don't 100% take my word for that. That's just what I gather from my general knowledge of our software.
Okay, no worries.
I have
All right.
a follow-up. So, in general, how does your software and hardware team work together to like manage timelines and make sure you guys have enough time to test and debug software?
Just do you want to take that one?
Yeah, typically for hardware and software, well, software may be developing like experimental like coding methods and sensors while the hardware's working on the robot. Hardware generally finishes 1 to 2 weeks before the actual, I think, competition. You can correct me if I'm wrong, so that the coders have time to fully like code each individual subsystem. But normally, actually, I think we do have time, like while hardware is working on the main parts of the robot, that the coders can test out like on just a smaller chassis. It doesn't have things on it, just basic routing. I'm pretty sure we did that last season. And then just once the hardware is done with like the majority of the robots, 2 weeks, 2 or 1 week before competition, the coders will then be able to use it and code for competition. And then it's after competition that the hardware does the improvements needed that we're seeing, or the deficiencies that we're seeing at competition. And the software gets at some point along the line from there.
yeah, we are not very good at giving our software people a lot of time to program the robot.
Yeah.
2 weeks before the competition is probably the better end of the spectrum.
Yeah.
Yeah, I know we've put Neil in some tough spots before. I think before our last like league tournament
Yeah,
or
don't worry
league
about it. You know, I was
league
coding.
meet.
Yeah, I think I was coding Vision Code Meet 2. So like inside of Meet 2. So
Yeah,
that was that.
we give them like 3 or 4 days sometimes. So yeah, y'all are doing better than us, but we're trying to get better.
So I have a question for you guys actually. How do you guys localize in autonomous?
Okay, so this is like the first year we like ever decided to do odometry or anything. And this is also my like first season on the team. And so we bought Go Build Odometry pods at like the start of the season because they were just coming out and they were on back order until like late September. So we weren't actually able to get a working autonomous working as in like but even having odometry on the bot. We had that by December and then over like that time from December to around um late January, February, I was working on, getting familiar with Roadrunner point 5, trying to get familiar with uh, using that code and tuning and things like that. And then, because Roadrunner was so like cumbersome to, I guess, tune, I never really retuned it. And so we really just like went for it and I just like created like a bare bones 2+0 autonomous just to get as many consistent points on the board as possible. Um, but the only issue was like the entire year, one of the biggest issues I was having was literally just random hardware or software like bugs. Like literally, I think the one time my auto worked was state. Every other time my auto would break or the robot would not move or something like that, just because there was some issue with the vision code or some issue with the like some issue with logic or something that was causing the entire thing to crash. There was actually one instance where I believe I like didn't close the camera stream and so it was bogging down the controller, causing the entire thing to just crash. And they had to like drivers had to like restart the like teleop code like mid-match because of that. So I think one of the issues we were definitely having was lack of time to test and just in general a little bit of a lack of what do you call it, like knowledge, I guess. I guess this is like our first year doing it, but yeah, so we basically just use three-wheel odometry and that's all we do. We didn't really use cameras because our robot we had just jerry-rigged our camera on the side of our robot because that was like the best scenario we had at the moment. And then yeah, that's just as much we were able to get.
So this year we're planning on making quite a bit of changes to the sensors we're using. Kind of like what you were mentioning, either using some sort of distance sensor or like color sensors, just so that way we have more consistency and Neil has more to work with instead of just trying to use localization and from three-wheel odometry all the time. Um, that's something we learned this year that was quite helpful for the upcoming years.
Yeah, I actually have another question for you guys. So in terms of like vision for autonomous especially, do you guys face issues with like lighting on the field and stuff like that? And if so, how do you guys like deal with that?
Pierce, do you want to take this one? We have a fun answer.
Lighting for the Husky or the camera?
Um,
Which one's the funny?
for the Husky mainly.
Oh, yeah. So this last year, we were having some lighting inconsistencies with our Husky lens detecting the pixels, because like the different levels of brightness in the environment will sometimes cause it to not detect pixels on either side. And I don't know, but there may have been some also false positives from like bright spots when we're not used to that brightness when we're tuning the Husky lens. So we fixed this by putting a bright LED like right under the Husky lens that pointed straight forward and illuminated everything the Husky was looking at. So this made it so that when we were tuning the Husky lens, we would tune it to a consistent light level so that during competition, no matter how the lights were set up, it would always be able to see the pixels and reliably see them, and so we could drive to them and intake them.
That's
And so
really
also,
cool.
Yeah.
so you mentioned using that. So the drivers would not have to worry about intaking a white pixel as
Oh,
in like, or are you talking about autonomous?
I'm talking about autonomous. We turned
Okay,
off
yeah.
the LED for teleop because if we use it for teleop when intaking from the human player, they will get blinded due to it
Oh,
constantly
okay.
turning
Oh,
on and off.
is it just like like a really big, like it's just a really bright like
It's
light?
just a bright
Yeah.
LED.
Oh wow,
Yeah.
all right.
Pierce
Like a
speaks about
flashlight.
being blinded
Yeah.
through experience.
That's
From
good.
that one time we tried using it, it would it's not recommended.
So that means, so are you saying that like the intake would not be controlled by like the driver? It would be entirely robot controlled, even in even in teleop.
I don't
Um, no.
Okay.
So
know.
the Husky lens was something that we've seen in the past can return false positives, and so we try and use it only in autonomous, only after we've tried to intake from the stack, knowing where we are, and after that doesn't work, we're like, okay, turn on the Husky lens, turn on the LED, and then usually at that point we're close enough to the pixels where it's not going to give us a false positive, and we're able to intake from there. In teleop, the goal is really to make our intake um, as good at picking up pixels as possible, and also to have as wide of a range for its size as possible. So in order to make it easier for the drivers, so that you don't need a software kind of crutch for the drivers, so that they can kind of run straight into the pixels and come back out.
Right.
One thing that the software did help with for our intaking is we had rev color distance sensors in our intake. And so we knew exactly when we had picked up 2 pixels. And we were also able to tell, if we had picked up 1 pixel, which side was it on? And we had this little LED on our robot that was LED display that was able to communicate that to our drivers and say, okay, we have a pixel on the right or we have a pixel on the left. Meaning, you have to start moving towards the side that your pixel isn't on to try and get that other pixel. And so as soon as we detected there is a pixel or 2 pixels, the intake automatically flips up. There's a rumble on the driver's gamepads and the LED screen changes. So the drivers instantly know, okay, time to start driving away.
Okay. So with that color sensor, that's like one last thing that I had a question about. Since we're planning on like implementing sensors this coming year, uh, something I was considering was something I like had no idea how it worked. Like, how do you guys like actually tell how many pixels are in your hand? Like, do you have like a two-handed claw?
We had
Uh,
a
go ahead.
spinner intake that could
Mhm.
fit 2 pixels in it side by side. And then above where the 2 pixels would get intaked, we had 2 separate color sensors pointed downwards so that
Okay.
once we intook one, we could tell which side it was on, and when we intook a second one, we could tell that we had both and then transfer.
Okay. So you knew for sure that your intake was guaranteed to take in at least 1 pixel. It's just that the color sensor was there to tell the drivers when you picked it up and if it was there.
Yeah.
Okay. All right.
Awesome. I think it's next time for our next trivia question. So this one's a bit trickier than the past two. Do you guys know why coffee beans were banned in FTC?
Do you mean banned on the robots or something else?
Yes, coffee beans were banned on the robots in FTC.
I have no idea why it would be banned on the robots. I could see it being banned in general to discourage FTC teams from pulling really, really late nights. I don't think that would work if they tried to stop us, but uh, yeah, I have no idea why they're banned on robots.
I have no idea either, but my best guess is that some team had it on their robot and then like the container for it broke open and spilled on the field and then it got ground up. But I don't see why that would make it that specifically banned, so I don't know.
All right. Any final guesses? All right. Well, you were on part of it. It is a mess. But the other part was actually teams were putting ground up coffee beans basically inside a balloon type material. And then they were using a motor to run a vacuum that was attached to those coffee beans in the balloon. And they could use that and basically use it as a universal gripper. And it could pick up any shape of object or any size of object just using that vacuum powered coffee bean contraption. So that's why they're no longer allowed to be used. So
Isn't
I
that
thought
like
that was a fun fact.
isn't that like a form of pneumatics or something like that? Or is that, am I
Yeah, it
tripping?
would be with, vacuum cleaner.
Huh,
Yeah.
it's kind of funny,
So
I can't lie.
yeah, very creative solution, I must say. I wouldn't have thought of it.
Yeah.
But
Yes, I've never heard of that.
yeah. All right. We have one more notebook question for y'all that I think David will take, and then a few more fun questions after that.
So regarding Notebook, how do you split up your work on like the portfolio or documenting stuff throughout all your sub teams and members?
Pierce, do you want to talk about that one?
Yeah, generally, aside from the parts that we procrastinate to closer to competition days, we generally, like each person, like if someone worked on the intake mainly, then the person that works on the intake will like put down like the raw info and statistics into like the format that the other documentation people created. And like they'll fill in the info, and then from there, the documenters will either, they'll like edit the section to make it look better, and then they'll ask like the person who either created the slide or someone who knows about it for more follow-up information so they can completely fill it out and just make it seamless. And then for like outreach and other events like coding and stuff, just the person who went to those events will like put down a description of what happened into like their group chat or whatever. And then closer to the date, when we actually construct the notebook page for that, we'll use both the description of what we did at the event by the people who went to the event and like the information of those that we were presenting to or the mentors we gained info from. And then we'll put that in the notebook as like how we either contributed to the community or like how the mentor contributed to our robot.
So when
So,
it comes
oh,
to
sorry.
your outreach, like how do you like communicate with the organization or a place to be able to do that outreach? Do you have like a particular method? Or like do you email, do you go in person, or do you have some other way?
I definitely say from our experience, there's no set method. You try emailing them, you try calling them. To be completely honest, calling them rarely works. Emailing them almost never works. The best way to do it is really to find contact, um, of someone you know or someone who you know knows. Just like any sort of person who is like someone where you know their actual email address rather than just the general company. Or if you want to volunteer at an event, or sorry, not volunteer, but like present at an event, try and find someone who's organizing the event rather than emailing the event in general, because then you're more likely to get a response. uh, it's actually a really funny story. So we're actually mentored by SpaceX, and so the reason we're mentored by SpaceX is that one year we cold emailed them, and because our team name is technical difficulties, it got flagged in their system. And so we have no idea what would have happened if we had been named anything else. But it got flagged. Someone took a look at it, forwarded it to the right people, and they actually replied. And it's been really cool. Uh, and that's actually a really crazy story, even to this day.
That's really awesome. Yeah, that's a unique opportunity. I don't think many teams would have that happen. So that's awesome.
So I'll finish with this. Is do you have any advice for maybe a new team? Um, Anything that they should know going into the season, something they should consider, or something that they should work on or know about before getting thrown in the deep end?
For,
Oh, go
yeah.
ahead, Pierce.
So if this is centering around notebook, I would recommend that whenever you either like make a design or plan out how you're gonna do the season, you write it down somewhere or take photos, just so that later in the year, when you're actually creating the notebook, you're able to use the photos of these like designs or workshops that you went to or etc. just to fill out the notebook and like use them as reference for information. Just so that no your team isn't just asking like what happened on this day and no one knows. So you always will know what happened in previous days, what previous designs were, and you can show the judges what that was.
That's
We're
good
gonna move on to
advice.
the most important question of this entire podcast. What is so there's an unknown problem on the International Space Station, and you are the only person that can fix it. What are you bringing? Duct tape, zip ties, or super glue?
Oh, that's a
I
hard one.
would,
I think I know what Pierce is gonna say, and I completely agree. It would have to be zip ties. Or am I wrong, Pierce?
I was gonna say duct tape, just because of how it's been used on past space missions. Cause you can use it for like wiring if needed, or if like there's an air leak, you can use it for that. It's just very versatile. Zip ties, I think they would just be used for wiring and holding things together. But you can do that with duct tape if need be.
I would say zip ties, not because it's the most practical option, but just because there has been no issue, no jank fix that I've made that hasn't involved at least one zip tie. If your chain isn't
Yeah.
tensioned, here's a quick tip. If you did your CAD wrong and you didn't do your chain tension, and so your chain tensioning is off, what you could do is you can take two bearings, can put a zip tie between them, and put them on both sides of your chain and tighten it, and it works. And that's something that stayed on our robot until like the end of the season, and until we finally got around to fixing those plates to have the right motor spacing.
It did occasionally break though, the zip tie, so maybe not a permanent solution, but it's definitely a good temporary one, like for a competition.
Yeah, how do you think our camera was mounted? 2 zip ties and a wad of electrical tape, I'm telling you. Using
Amazing.
literally the electrical tape angled it downward so it could like look at the spike mark. That's it.
Peak
That's pretty.
engineering.
It actually it like didn't change. Like we kept that. It's still on our robot to this day.
Yeah.
Which is pretty fire.
That is true.
Yeah, there's from Freight Frenzy, we had our butterfly drivetrain. And so during an off-season competition it broke, right? And this is like right before the eliminations of this competition. And so what broke was like a 3D printed spacer that goes on the shaft that holds all the wheels. And so
Huh.
there was no way that in the time we could like take the shaft out and put on one of the spare spacers we had, because it's something that you have to put like on from the side of the shaft. You can't like just like squeeze it on. And so what we
Mhm.
did is we have these kind of like TPU clips that we put on our like drivers so that we know like what size they are just by looking at the color of the clip. And so we took one of those clips, we cut it to the right length. We wrapped it like it was just big enough to go almost 3/4 of the way around the shaft. We wrapped it there, and then we put a zip tie, and that held the bearing that was gonna fall off without that spacer in place for all of eliminations. And if you go back and you look at that robot today, it is still on there. So
So the moral of the story is zip ties, duct tape, all very useful to have all the time.
yeah,
Yeah.
Yeah, I agree.
All right. Well, we're getting towards the end, so one of our last questions is we're all excited for the water game, but what are y'all expecting for this season?
It's gonna be interesting with the extension limits, so that's probably gonna change a lot of like the world's robots. And my personal prediction, I have no clue if it's right, but I think there's gonna be like a center object similar to like Rover Ruckus. But I may be completely wrong.
so this isn't my expectation, it's my hope, is that it's a shooter game. If the GDC still hasn't decided, which I know they completely have, they could try flying fish, that would be interesting. I don't know how exactly they'd relate it to be a relevant issue in today's world, but maybe shooting garbage out of the ocean is an issue they want us to explore. So I have my fingers crossed for a shooter game.
Yeah, but the thing is,
Yeah.
it's also like into the deep like trenches, so I don't know how shooting trash, so it'd
Yeah.
work. Yeah, who knows?
We'll see. I'm also hoping for a shooter game because the year I joined was right after Ultimate Goal, and so I never got to do a shooter game. So I'm really hoping that's what it is.
what if it's like terrain like navigation? Like they just have like a giant like rock in the middle of the field and you just have to climb it.
To
That'd be pretty
climb it
fire.
and put the thing in.
Yeah, that'd be pretty fire, I
Yeah.
think.
That
That
would
would
be
be.
pretty
Okay.
cool.
That would.
It would give us another
Um,
reason to not use dead wheel odometry again for the fourth season in a row.
That's good.
That is true. Yeah. All right. Well, very, very last thing. Is there anything you want to tell us about, tell the people that see this podcast, whether it's outreach events that are upcoming for y'all, anything like that? Feel free to share.
Pierce, do you want to go if you have anything?
I mean, I guess we're co-hosting kickoff on the
Yeah.
7th of
This
September.
is for North Texas teams. We are co-hosting the kickoff at Marcus High School. That's a shameless plug. But also, this is a fact that might blow some people's minds. We do not use Android Studio. I didn't get to say this in the programming section. We don't use Android Studio. We use onBot Java, and we don't use Roadrunner. We don't really use any external libraries, and so as a result, we make our own. But the reason we do this is for faster build times, and I kid you not, the faster build times have saved us. Like when you're tuning your autonomous to work with your partner during a competition, faster build times have saved us so many times. Um, you know, I would recommend other teams to use it, but then I'd sound like a crazy person. So I'll just leave it at the fact that we use it. If you guys want to use it, it is doable.
That's
Right.
yeah. It's pretty fire from you guys, really. Wait, so you guys like program like your entire odometry and everything just in onBot?
Yep.
That's pretty heat, I cannot lie.
It's impressive. All right. Well,
Last
I
thing I'd
guess.
like to mention is a thank you to our sponsors for helping make our team happen and making this podcast happen. Our two Leviathan sponsors are the Society of Petroleum Engineers of the Kona section and the FOB Memorial Foundation. So thank you to our sponsors. Thank you for joining us on this podcast. We hope you enjoyed it, and we hope to see you throughout the season.